Hello, trigonometry student. This video is for a material in 10.3. I recorded it so you can catch up with the material even if you are absent on the day of the lecture. 10.3, the topic is polar coordinate. We introduce a new way to identify points in space and also identify a function or equation that can be plotted in space. And when we say space, we're not talking about 3D space, but a 2D um, planes. Okay, so our old method of identify a position in a space is called the Cartesian coordinate because this coordinate system is invented by Descartes, and basically is x, y. It is also called rectangular coordinate sometime, or actually a lot of times, a mathematician also call it the rectangular coordinate system, where you have the x-axis and the y-axis. Every single point is identified by how much you go across. For example, this is 3, comma 2, because you go across 3 and then you up 2, right? So that's called the rectangular coordinate system, or this point 3, 2 is a rectangular coordinate. Now, it's when we identify these space, you can actually when we grab the xy coordinate, we usually label 1, 2, 3 whole number, but presumably you can have 1.23 and then up 0.55. So every single space has one number in this coordinate system. The new coordinate system we want to introduce is called a polar coordinate system. The reason why we want to introduce it is there's some certain graph and certain graph and certain function, it is easier to write the equation or plot them if we use a polar coordinate, particularly a graph that involves a trig function. So for example, so how do I read this coordinate? So this coordinate doesn't have rectangles. Yeah, it still had a axis. You can see that it still have x-axis and y-axis, but we don't use them. We use two things. One is the pole, which is the origin. We call it the pole. It's 0, 0. And then the other is called the polar axis, which is the positive axis here. This is called the polar axis. We don't care about the negative side or this two. So all we want to know is this is a pole and this is the axis. What do we use it for? And then out of the pole, we would have circles. So the first circle is radius 1, the second circle is radius 2. Presumably, you can have radius circle of radius 1.2, 1.34. So every single point in space is on a particular radius. So the radius is how far away that point is from the pole. And then the other number that we use to identify a position in space is a theta, is the angle. How much that particular point is from the polar axis in a counterclockwise direction. So, for example, they have this ready-made line that is, the radiate from the pole. So this is a pi over 6. That means every single point on these are in a certain radius, but the angle from the polar axis is pi over 6, which is 30 degrees. So this is pi over 6. So if I want to, for example, I want to identify this point. So this is the radius is 9, right? And it is at a position that is pi over 6 from the polar axis. So I will call this point 9 comma pi over 6. Basically, you tell people how far away you are from the pole, 9 away, and also how many degree you have to, or how many angle, what is the angle in radian you turn to get to that point. And this particular identification is called polar coordinate, and this grid is called the polar grid. Usually we label them as in the polar axis, we label them as 1, 2, 3, 4, 5, 6, 7, 8, whatever. And then we don't have just the y-axis, we have all these radian outline that tells us the special angles. So pi over 6, pi over 4, pi over 3. Okay. And then 2 pi over 3, 3 pi over 4, all these. And so it's from 0 to 2 pi. We could actually label all of these can be labeled in a negative way because although this point is as pi over 6, we can actually say this is 9, but the angle is backward, negative 11 pi over 6, right? So it is coterminal. Pi over 6 is coterminal of negative pi over 6. Why? Because I turn this away, right? If I turn this, I go 11 pi over 6 to get to here. Another way, an example would be here. If I have a point here, how can I label it? I will label it as, yeah, this is 5 away from the pole. So the R is 5. So say 5. And what is the angle to from the polar axis? I can do positive angle, which is 7 pi over 4. Or I can say 5. But I want to do the negative, like the clockwise rotation, negative pi over 4 also. So they refer to the same point. So unlike the rectangular axis, there's only one way to write your x and y. The polar coordinate actually has different coordinate that refer to the same point. So in this particular case, if I say this is point B can be written as 5, 7 pi over 4, because this is actually 7 pi over 4 all the way turned here, right? Or I can say 5, negative pi over 4. Of course, both the R and the the angle is positive is more common, but they're actually the same point. Okay. Um, Another thing that is interesting is other than the angle have positive and negative, the radius can be negative also. So what happens if it's a negative radius? It just means that it's going the opposite direction. So look at this point B, right? I can say it is 5, 7 pi over 4 or 5, negative pi over 4. I could actually say, well, why don't we don't use this line, but use the opposite, which is pi away from it, which is 3 pi over 4, right? This is, I think, 7 pi over 4 is the opposite direction is 3 pi over 4. And I want to put a point that is 5 away from it also. Is this 5? 1, 2, 3, 4, 5. 5 away from it, but I want to do in the opposite direction, which is so if I do C, which is what? 1, 2, 3, 4, 5. I don't know. It's yeah. So this point C, let's say this is A. Okay, this C actually is, so maybe I write here, C is actually 5, 3 pi over 4, right? But what is negative 5? Negative 5 would go this direction and it would become B. So actually I can say negative 5, 3 pi over 4 is the same as B also. B can be written this way, or this way. You can have a negative R because you are going the opposite direction. But for the angle, I keep 3 pi over 4 because it was the 5, 3 pi over 4 was originally here. If I go negative, the radius would be opposite to it. It's kind of like vectors, like you go opposite direction. So negative 5, 3 pi over 4 would be B. Although the angle is 7 pi over 4, I would still write 3 pi over 4 because I have a negative radius. So, but these two are not as, as popular, but I just want to tell you that they're equivalent to 5, 7 pi over 4. So that is kind of like the difficult part of naming a point in the polar coordinate. There is multiple way to name a point. So let's do some example. Example 1 is identify, someone has the point, identify P where R is positive. So let's say P is 1, 2, 3, 3 from the pole. So it would be 3, and I want R to be positive, so that would be it. And then what's the angle is 2 pi over 3. That's it. What about Q? Q is here. How far away is it? 1, 2, 3, 4. 4 from the pole. And what's the angle from the from the the polar axis? I can say 11 pi over 6, positive 11 pi over 6. Or I can say 4, negative pi over 6 also. So there's both are the same thing, right? Because just the angle is opposite. What about if I want r to be having the same point q, but I use a negative r, then I would look opposite to this direction and with the same location. So I would say negative 4, but I use this angle, 5 pi over 6. Why? Because the actual 4, 5 pi over 6 is here. And if I go negative, it would go this direction and become q. Okay, so this is q and this is q. Example 2, so plot the points. 3 pi over 3, 3 would be 3 away from the radius is any point here, but I want the pi over 3 one, so I want to turn pi over 3, 1, 2, 3, pi over 3, so it will be this point, so this is A. B is 2 and then negative pi over 6, so I would be at 2, but then negative pi over 6 is going down, right? Going the clockwise direction, so it would be as is the 11 pi over 6. So this is B, still positive R. Now C is a negative R, so we will find the positive R first at pi over 2. So positive R of 3 would be 1, 2, 3, and then I want to have pi over 2 is here, right? So it would be here, but this is not what I want. I want a negative 3. So this is 3 pi over 2. And then if I want to go negative, it would go down this way. So this is C, because this point that is opposite to it is actually 3 and pi over 2, because pi over 2 is here. If you have negative, that means you have to go opposite. So that would be C is actually 3 pi over 2. It's the same point. What about D? D, I want 3, 4 pi over 3. So this is positive and this is counterclockwise direction. So I go 3 again, and then I go 4 pi over 3 is here. So this is 3 away from the pole. So this is the point D. So that's how you plot it. So hope you understand the negative R, positive R, negative angle, positive angle. Okay. So that is the basic. So it's this page 1 of the notes. And in the second video, we'll talk about how to change a coordinates between polar coordinate and rectangular coordinate.